Alright, so we're going to convert this equation into a quadratic. It originally doesn't look like it is quadratic. However, after one step, we'll find out that it is. This x right here is the problem. Whenever you have a variable in the bottom of a fraction, it's nearly impossible to solve for. So the first step that we have to do is multiply through by a factor of x to everything. Now, if you multiply the left-hand side by x, you multiply the right-hand side by x, it'll still be equal. However, it'll appear a little different. So 10x is over on this side. And now if we distribute this x here and to here, 3x squared is created. And then if we multiply this by x, but then later divide this by x, the x's actually cancel out, which is the purpose of that step, and leave us with just plain old 5. And this is now more obviously a quadratic, except it's still not in the correct form. You can't solve a quadratic if we have it equal to something other than 0. So last step, combine some like terms, or rather combine them on the same side, all the terms. X squared minus 10x plus 5 is now equal to 0. And once that happens, equal to 0, then we can use quadratic formula. A is how many x squareds, which are 3. B is how many x's, -10. And C is how many singles we have is 5. Just the plain number there. All right, here's the same concept, although quite a bit more challenging. This is going to take the same type of step, but 2 different times. We're going to have to do this once with the x to remove the x from the denominator, and then again with this factor x minus 5, that's a 5. And I like to start with the easier one. It tends to make it look better faster. And so in a problem like this here, let's multiply the right-hand side by x so that these factors cancel. And we're going to multiply all of this by x, and so that multiplies here, n to the 3. Now what that looks like when this happens, 10 is over here. That one's easier to do. Minus 3x, that's also not so bad to do. And then when we multiply here, let's write this as x times x plus 1 over x minus 5. I don't quite want to multiply that through yet, but that's what it would look like. X times x plus 1 divided by x minus 5. So we're at least done with the fraction of over x on this side. We still have to deal with this x minus 5, and we'll take a similar step now. Multiply x minus 5 to both sides. Okay, and that x minus 5 will distribute, and it will actually cancel in this case here, x minus 5, but it also distributes over to this minus 3x. Now, when we write this out, it's going to be 10 x minus 5. That's the easier part to do. Then I better write this. This is the next easiest part to consider. Negative 3x, x minus 5. And then if this x minus 5 is multiplying, it's actually going to cancel with the x minus 5 that's in the denominator, which is the purpose of this step. And we're left with x plus 1. Okay, it doesn't look so great, but at least it's not a fraction. There's no fractions. So from here we have a much easier algebra to consider. So we have a lot of combined like terms steps to do. So we're going to distribute this 10. We're going to distribute a negative 3x, and there's a double negative here with the 5. So we have to consider that will eventually turn positive. And we have to distribute this x. So let's go ahead and simplify this. It'll be x squared plus 1x. Then the next will be negative 3x squared. And then plus, usually that's the part students maybe miss, is the double negative there. 15x. And then 10x minus 50. Okay, even easier now. We got to get all of our terms together on the same side and combine any that are considered like terms. And even before, I see I can combine these two, negative 2x squared, and these two, positive 16x. Okay, so I combined the like terms that I could on the same side here, and now we have to balance the equation so that we have 0, and doesn't much matter which way you do this. Actually, I tend to like the leading coefficient to be positive. So in this case, I'm going to aim for 0 to be on this side of the equation and instead move these to the other side and get a positive a value. So we would have to add 2x squareds, and we would have to subtract 16x's. It's not lined up, but it's okay. So overall, we would have positive 2x squareds, and that's the reason I wanted to move it to this side. We would have minus 6x, the 10 and the minus 16, and then the minus 50 is not like the others, cannot be combined. So there you have it. A is 2, 2x squared, b is negative 6, and then c is negative 50.